I'm Ellen Music. I'm a senior software engineer on the infrastructure team at Textio, and I'm here today to tell you about how we use AWS Lambda to build Textio. When I joined Textio a couple years ago, I was fascinated by how easy it was to build and deploy services using Lambda. And I was also fascinated by the many different ways in which we use Lambda and by the impact that Lambda has had on how we build. So when I got the chance to prepare a talk for reInvent, I knew that I wanted to talk to engineers from around the team about how they were building with Lambda to bring you tips and tricks, interesting patterns, and share what we've learned with you today. I've organized all those conversations and themes into this presentation. I've organized the conversations into 3 use cases. But before I get into the use cases, I want to give you some context about Textio. So first, I'll explain what Textio is, how we build it, and how we use Lambda. And then I'll talk about how we think about using Lambda as we're going to build a new service. And then I'll spend most of the time jumping into the 3 different use cases. The first use case is from the web applications team. This team is responsible for the development and maintenance of the Textio.com web application, as well as building internal tools for Textio employees. Many of these tools and parts of the web application are built with Lambda. The second use case is from the product services and data science teams. The product services team is responsible for backend microservices and data engineering. Many of the microservices and data products are built using Lambda. The third use case is from the infrastructure team. That's the team that I'm on. We're responsible for building the tools and components that other teams use to build. For example, the container registry, operational metrics, networking, things like that. We also use Lambda either to build services or to extend services. My goal for you today is that you'll walk away with an idea of one more place where you can use Lambda, or some tips and tricks that you can use as you build with Lambda. If you're here, I'm assuming that you're interested in Lambda and that you have an idea of what the programming model is. For example, you know it's an event-driven programming model where you write a function and then define a trigger that specifies when the function should be executed. I'm not assuming that you're familiar with the nitty-gritty of building Lambda services. For example, if you don't know what reserved concurrency is, that's OK. And I am assuming that you're OK with getting into AWS services. For example, I'll talk a little bit about auto-scaling groups, but first I'll define what they are. Also, I have practiced and practiced to remember to explain acronyms. There's so many. So to get started, I'll explain what Textio is and how we build it and how we use Lambda. Textio is an augmented writing platform. Textio tells you how well your words will work as you're writing them. We use data from more than 500 million documents and real-world outcomes to tell you about the impact of your words. This is the future of writing, knowing how you sound as you write. When Textio was founded 5 years ago, it began as a Python app hosted on a platform as a service provider. As time went on, we moved into AWS, and we began using Empire as an open source orchestration layer on top of Amazon's Elastic Container Service, or ECS. However, as a couple years passed, occasionally there were things that we wanted to build that we wanted to automate that didn't fit as well with the ECS service. For example, we wanted to take CloudWatch alarms and add some information and send them to Slack. Or we wanted to run some code every day to sync some data just easily. So about 3 years ago, we started using Lambda at Textio. And when I was preparing for this talk, I was very curious how many Lambda services we have. I feel like I'm always hearing about a new one, so I was so excited to dig in and find out what they were. And I'm using service here to mean code and infrastructure as code, for us, CloudFormation, usually combined together in the same repository to provide some kind of business functionality. So for example, this might look like several Lambdas and a queue and a data store that take some data, transform it, and upload it somewhere else. As you can see, the number of Lambdas has increased, or the number of Lambda services has increased drastically over the last 3 years. Last year, we had 20 engineers at the beginning of the year, and we ended the year with about 20 Lambda services. This year, we had 50 engineers at the beginning of the year, and when I pulled these numbers a few months ago, we had 80 Lambda services. So the robots are winning. So what do all these services look like? What are some of the common patterns that we use with Lambda to build Textio? If you've used Lambda at all, you're probably familiar with some of these patterns, even if you've read online. We use Lambda for building APIs. We use Lambda to build the Textio blog. Or we use it to back command line interfaces. As a variant of this, we often use Lambdas to build an asset and then an API for that asset. For example, we might use a few Lambdas to crunch some data together into a JSON file and upload it to S3, and then a couple more Lambdas to query that data to return results. We use Lambda for extract, transform, load pipelines, ETL pipelines. This is the example I gave earlier to take a CSV of documents, split them into rows, transform each row, and then upload them to a data source. We use Lambda with AWS Kinesis as an event stream. We use Lambda for message translation and forwarding. We use Lambda for cron jobs. We use Lambda for infrastructure automation, for example, to automate backing up GitHub. And we frequently use Lambda for spiking or exploration or prototypes. When we're building a service and we're not sure yet what architecture we want, we typically start with Lambda. So what have we learned from all these 3 years, not that long, but 3 years of using Lambda? Well, we default to Lambda when we build new services, but we also use other AWS services like the Elastic Container Service or Batch. So when we're going to build a new service, here's how we evaluate whether or not to use Lambda. This breaks down into 3 categories. The first category is around the constraints that Lambda has. Does the work that needs to be done fit inside those constraints? Does it fit within the, last time I checked, 15-minute execution time? Does it fit within the memory and the space constraints? Although sometimes we can escape those constraints, so a couple tips. If you run into the execution time limit, sometimes you can batch up your work or parallelize it with using threads or something like that, so that you can fit inside that execution limit. We have also a couple times downloaded, instead of including dependencies in the deployment package, downloaded them at start to get around that constraint. The second category is around the events that AWS provides. When does your work need to happen? When does your function need to be executed? Is there a matching event or trigger that you can use? The third category is around what do you want to optimize for? What do you want to spend your time doing? Is it auto-scaling important? Do you want that out of the box? Or do you need more control over your development environment? And actually, there's a fourth category. Historically, cold start in the VPC or virtual private cloud has been a big factor in whether or not we choose to use Lambda. But there's an asterisk there because changes that were rolled out last week to networking and the, provision concurrency that was released yesterday or the day before, I think will mean that this is no longer a factor in our choices, which is really exciting. Okay, so now that you know more about what Textio is and how we use Lambda and how we think about using Lambda, let's jump into the use cases. The first use case is from the web applications team. This team is responsible for the development and maintenance of Textio.com, and they also build internal tools for Textio employees. Meet Komal and Megan. Komal and Megan are both engineers on the web apps team. One of the tools that this team is responsible for is called usage reports. This tool is used internally by customer success managers to understand customer health and product usage. Here's a screenshot to give you a mental picture of what we're talking about. So a CSM can go to this tool, enter an account ID, and request a report, and then they get a report with beautiful charts and graphs and data insights about the customer account. Kamal and Megan need to make some updates to this application. There's product changes that require the graphs and the data insights to change and be added to, but they also want to make 2 other changes. So currently, the CSMs, the customer success managers, are manually, at the beginning of the month, going to this tool, entering an account ID, and requesting a report. And then for the next account, they enter an ID and request a report. And then for every account that they're responsible for, they request a report. But Kamal and Megan want to automate this for the CSMs. The second thing they want to change is to move this application into the cloud. So when it was built as a desktop application, and that makes iteration time slow. In order to push updates out to the CSMs, Kamal and Megan had to update the application, upload it somewhere the CSMs could download, and then prompt the CSMs to download it. Obviously, that's error-prone, and often CSMs ended up on an older version. So Kamal and Megan want to update that. So can we use Lambda to build a service for monthly and on-demand account reports? If we go back to the 3 questions I mentioned, the first one is fit. Does the work that needs to be done fit inside the constraints that Lambda has? Yes. For monthly reports, we can generate a report request for each account within the time frame that Lambda allows. The on-demand reports can be generated within a Lambda, that it fits within the execution time and the other constraints. The second question is, when does this work need to happen? Is there a trigger we can use? Yes, for monthly reports, we can use a CloudWatch event. And for the on-demand Lambda, we can use API Gateway or Amazon's Application Load Balancer, ALB. And lastly, what do we want to optimize for? What do Kamal and Megan want to optimize for? Well, this is actually their first time building a back-end service, let alone a Lambda service. So they want to optimize for getting something working quickly, and they also want to make it easy to parallelize the monthly reports. So it seems like Lambda's a good fit. So this is the architecture that they began with. And if you look in the upper right-hand corner, you can see there's a static website hosted in an S3 bucket. The customer success managers load the static website from the S3 bucket, and then they fill out the form that I showed you a couple slides ago and request a report. Requesting the report sends an AJAX request to an API gateway, which authorizes the user using Amazon Cognito and triggers the on-demand Lambda. That Lambda puts a report request into a queue, and then another Lambda is triggered based on messages in the queue. That Lambda, the report generator Lambda, makes calls to data sources and runs code to create this beautiful report for the CSMs. It then uploads the report to S3 and Dropbox. For the monthly reports, a CloudWatch rule triggers a Lambda once a month. That Lambda generates report requests for each account in the queue. Well, that was great. It's working great, but there's one challenge. Kamal and Megan want to increase security for the static website. For static websites hosted in S3, there's roughly 2 options. One option is to make it available to everyone on the internet, and the other option is to make it available, only to people in your network, so people in your VPC. But Kamal and Megan want to restrict access even further. We don't necessarily want everyone at Textio able to access these reports since they contain customer data. So to make those changes, Kamal and Megan made some architectural changes. And I'll walk you through 3 architectural changes on this slide, 1 commonly reused pattern, and then some pros and cons from Kamal and Megan. So the first change is the main change to restrict access to the static website. Instead of CSMs downloading the website directly from the bucket, the request instead goes to a proxy ALB, which authenticates the user through Amazon Cognito, and then the proxy is responsible for returning the website. So now we have authentication for people accessing the static website. As often happens, one change begets another change. So in this case, the other change was to route the traffic to request a report also through the proxy. And that was because the token that we get from Amazon Cognito is only valid for a single domain. And traffic from the static website was from one domain, and before we changed the traffic to flow through the proxy, the domain of that traffic was to the execute API Amazon domain. The third architectural change was to move from using API gateway, a private API gateway in front of the request generating, or the on-demand Lambda, to using an ALB. And that change is simply so that we could use a custom domain name for the Lambdas. Private API gateways don't allow you to use a custom domain name currently, last time I checked. So now that we've talked about the three architectural changes, let's talk about this queue report generating pattern. Pardon?
What is Lambda ALB?
It's an application load balancer. Yeah. OK, so this queue Lambda pattern. This is a pattern that we use a lot at Textio. And in this case, we're using a queue with a Lambda so that we can throttle access to the data sources. Lambda has a concept of reserved concurrency. So you can set a reserved concurrency property on your Lambda and limit the number of functions running at once to that concurrency. There's another aspect of reserved concurrency that's also good to know. If you're running a lot of Lambdas in one account, all your Lambdas have a pool of concurrency that's shared between the Lambdas in your account. But if you set a reserved concurrency for a Lambda, you guarantee that that concurrency will be allocated to that Lambda. So setting the reserved concurrency on the report generating Lambda has two benefits. First, it ensures there's always concurrency available for those executions. And then it also allows us to restrict the amount of connections to these data sources. If you do use this pattern, a couple things to be aware of. For the queue, you'll want to set up a dead letter queue, and you'll also want to make sure to set the maximum receive count and the visibility timeout in the queue. You should set the maximum receive count to 5 or 6, and the visibility timeout to 6 times the function execution time. So I especially wanted to hear from Kamal and Megan what this experience was like for them, since it was their first time building a Lambda service. So Kamal and Megan they really liked Lambda from the perspective of how easy it was to parallelize and schedule the monthly reports. And they found it really easy to get an initial Lambda working, but they found it difficult. They found it more difficult when it came to putting all the services together with our existing services. So for me on the infrastructure team, this was something to think about as we think about how to empower other developers. And before moving on, let's consider the impact of this architecture and the benefits of this service. So now that we have this Lambda ALB and the proxy ALB and the proxy and Amazon Cognito, we can reuse this pattern. And Kamal has written a CLI for users to quickly deploy similar applications. So at Textio, if you want to build a static website and a Lambda for an internal tool, you can use Kamal's CLI to quickly do that. And that also gives us security by default. Since the proxy authorizes users, we get that security by default. The other trade-off I want to talk about here is the ALB versus API gateway cost trade-off. And we actually spend a little more money using the ALB, but it's the difference of about $15 a month to less than $350. And for the benefit that we're getting with a custom domain name, we were happy with that. But if you're thinking about a similar trade-off, A good thing to know is that the ALB is better for high volume. You'll save more money with the ALB at high volume, but the API gateway has a different feature set. So if you're thinking about building something similar, that is a tip for you. And I always like to actually ask the customer, how did you find this tool? Is it working for you? What do you think? So here's a quote from Bex, who's a senior data insights manager at Textio. And this data insights team also uses this usage report. Bex says, every time I run a usage report, I'm grateful for how easy and user-friendly it is to pull a usage report now, which means I'm way more likely to do it and to find ways to use this meaningful info with our customers. Thanks, Kamal and Megan, for making this possible. Moving on to the second use case. So this use case is from the data science and product services team. The product services team is responsible for building backend microservices to support product development and also data engineering. Many of these microservices and data products are built using Lambda. Meet Devon, Kelly, and Ted. Devon and Ted are engineers on the product services team, and Kelly is a data scientist. Kelly has been working on a project to better understand how customer behavior impacts retention, and to provide that information to the customer success managers in the form of metrics that help them understand the health of their customer. Kelly has written a Jupyter notebook that both collects and analyzes data, and now that Kelly's analysis has been solidified, now that she's done so much hard work to get this understanding of our customers, we want to quickly move this into a pipeline so that we can start pushing the metrics to Salesforce and start iterating with the customer success managers as our understanding develops. Looking at Kelly's notebook, there's 3 things that we would want this pipeline to do. We needed to collect data from 5 different data sources. We wanted to aggregate and analyze that data to produce business metrics. And we want that data to be uploaded, we want those metrics to be uploaded to Salesforce. So can we automate data science using Lambda? Is Lambda a good fit here? Going back to the 3 questions, fit. Does the work that needs to be done fit within the constraints that Lambda has? Yes, the calls to the data source and the analysis and the aggregation fit within the constraints of Lambda. Trigger. When does this work need to happen? It needs to happen once a week or on a schedule. Great. We can use a CloudWatch event for that. And then finally, what do we want to spend time on? Kelly has already done so much work to get this analysis to where we are, so we want to quickly move it into an automated process so that we can begin to iterate. Lambda's a good fit for building this service. So I thought about this, and I was like, how would I build this? Looking at that flow chart, how would I turn this into a service? So on the right, you can see that we get some data from Salesforce, and then in parallel, we make the calls to the data sources, and each Lambda that makes a call to a data source uploads that data to S3, and then once all that data is in the bucket, we can aggregate it and analyze it and output and upload it and reuse the code that Kelly had. But if you've used Lambda before, you might have a question about this. The challenge with this is orchestration. Once we do the work on the left, or on the right, to fetch all the data and upload it to S3, once each of the Lambdas that fetch data is finished running, how do we know that? How do we know that we can begin the aggregation and the analysis? And if you think about the available triggers that Lambda provides, you might have some ideas. You could run a cron or a Lambda triggered off of S3 uploads to check and see if all the data's there. But then what happens if one of the Lambda fails? How long do you wait? What do you do if there's an error? Well, fortunately, there's an easier way to do this using the AWS Step Function service. This service addresses those exact challenges. And I really wanted to share this with you today, because as I talk to people from around the engineering team, I heard time and time again, oh yeah, well, last year I built this thing, and now looking back, I realized I should have used a step function. So that's one thing that I want to share with you today. If you're not familiar with the step function service, it's a service that allows you to put together tasks into workflows called state machines. Each state in the state machine, or task or step in the workflow, can do one of a number of things, and then specify which thing should happen next. The two types of states that are most relevant for this state machine are the task state and the parallel state. A task state can do some work, for example, by invoking a Lambda, and a parallel state can begin parallel branches of execution. So for a parallel state, you can specify a list of branches, and those branches might be task states that do some work. So walking through the changes to turn this into a step function, you can see it's really not that different. So on the right, when we make a call to Salesforce, we define a task state that invokes a Lambda. And then that task state specifies the next state is a parallel state that has 5 branches of execution. Each branch is a task state that fetches data from Salesforce, or fetches data from somewhere, and uploads it to S3. And then the step function service takes care of knowing when the parallel branches of execution are finished, and the next state, the aggregate state, can begin. There are 2 core advantages of step functions that I want to point out here. The first one is the parallel state. We no longer have to write all that code and error handling to pull the S3 bucket and to find out when the Lambda has finished executing. With a couple lines of configuration, we can specify that the step function service should handle that for you. The second core advantage is the communication between steps. The step function gives you a place to encode logic about your workflow as a whole. And 3 examples of this. So the step function provides exception handling and retry logic built in. For example, for the fetch replica data state, you can specify an exception that you want to handle and a state that should be executed if that exception is raised. Another example, you don't have to add logic to pass data through from state to state. The step function service handles that for you. It passes the output of one state as the input of the next. And then third, you can write conditions that look at variables in the state. A couple more tips from Devon and Ted and the team about building step functions. With step functions, make it easy to move to AWS Batch or Fargate if your service outgrows the constraints of a Lambda. Executions that pass large payloads of data can be updated by using an S3 bucket. So if the data you're passing between states grows past 32 kilobytes, you can use an S3 bucket to store that data instead and pass a GUID or a pre-signed URL between the states. There's 2 more advantages that are easier to show here than tell you. And the first one is this visual representation of the pipeline. So when you go to the S3 console, you can see your step function workflow printed out like this. And you have to kind of tilt your head from the previous slide to get the picture, but it's there. The other benefit is the easy introspection into the individual steps. You can click on a failed step and see the error message in a central place. So reflecting on this service, we have a new pattern for reusing shared code between Jupyter Notebook and Lambdas to deploy a data science analysis. So data science and software engineering can collaborate on this shared code. The data scientists can update it and deploy it without needing an engineer's involvement. And while this new pattern does require some additional, this new pattern, the first time we use it, did require some additional work, like working with the data scientists to extract shared libraries from their code. We're already reusing it to build other services and to build onto this pipeline. So from the engineering side, we have a new way to work together, but from the business side, we're starting to get a better understanding of customer experience. Here's a quote from Liz. Liz is a manager on the customer success team at Textio. And Liz says, having the ability to track statistically significant retention metrics at this stage of Textio's journey is an impressive accomplishment. The signal that these metrics give the customer success team is incredibly important when we look at a holistic view of customer health. Okay, you're getting a sneak preview. The third use case is from the infrastructure team. And on this team, we're responsible for continuous integration, operational metrics, the container registry, things like that. And we often use Lambda as we build or extend services. Meet Lee. Lee is an engineer on the infrastructure team. And before I dive into what Lee is building, I want to give you some background. So while we typically default to Lambda, we do use other services. One of those services is Amazon's Elastic Compute Cloud, or EC2 instances. And if you haven't worked much with them, I want to define two terms before we dig into what Lee is working on. The first one is Autoscaling Group, or ASG. An autoscaling group is a group of EC2 instances managed together, especially for the purposes of autoscaling. And for what I'm about to talk about, the important thing to know is that you can specify a desired number of instances in the group, as well as a min and a max, and the autoscaling group handles keeping that number of instances at the desired number. The second term is Amazon Machine Image, or AMI. And AMI is a template for your instance, which provides the information required to launch it. For example, if you're planning to use it for machine learning, you might create an AMI with some machine learning libraries. Or if you're planning to use it to host a web application, you might create an AMI with that web server already installed. From time to time, these AMIs need to be updated, especially as new versions of packages are released. Maybe your web server had a security vulnerability, so there's a new package. The AMI needs to be updated. And this is where what Lee is doing comes in. So we use CloudFormation as our infrastructure as code. So Lee's workflow to update the AMIs looked like making an update to the CloudFormation, and then deploying that update to AWS, and then by hand, for each autoscaling group, terminating some instances with the old config, waiting for the autoscaling group to bring the number of instances back to the desired count, and then going back and repeating the process, terminating some instances, and then waiting for the number of instances to come back to the desired account. Doing this by hand is onerous. It's not that fun to keep going back and turning off instances and waiting for them to come back. And it's also error-prone. Shutting down too many instances could bring a whole service down. So can we use Lambda to automate this? Yes, we can use Lambda to automate rolling out AMI changes. If you think about the three questions again, fit, what are the constraints that Lambda has? Well, we can write the code to execute in the time frame that Lambda gives us. And what about trigger? When do we want this work to happen? We want this work to happen constantly in the background, and we can use a CloudWatch to trigger a Lambda that runs on a schedule. And then last, what do we want to spend time for? What do we want to spend time on? Lee is tired of doing this by hand, and he would like to use his time for better things. We want to spend time on automating this and getting it into the cloud quickly. So here's what it looks like to automate those autoscaling groups with Lambda. Each autoscaling group that's eligible for automatic updates is tagged, and then every hour a Lambda is triggered by a CloudWatch event. This Lambda gets the tagged autoscaling groups from using the Amazon APIs, and then it determines the current state. For example, if there are instances to be terminated, or if there are instances that need to be updated, and then it looks at the min and max and desired count of the autoscaling group. It then takes one of 4 actions. If no instances need to be updated, it waits. If the number of instances is less than the desired count, it waits. And then it scales down if there are more than the minimum number of instances. And then it scales up if instances need to be updated and the number of instances is at the desired count. So it knows the target state, it finds the current state, and then it determines the next step. There's one wrinkle here. Amazon ECS doesn't drain containers. So I've mentioned a couple times we also use Amazon's Elastic Container Service, or ECS, to run Docker containers in the cloud. And currently we have some ECS clusters where we manage the EC2 instances ourselves. They're not using Fargate. And when the previous Lambda terminates an instance, ECS doesn't automatically drain containers off that instance. There's an asterisk here since it's on the AWS Containers roadmap, which is available on GitHub. But in the meantime, how do we extend this service to add this feature? We can use Lambda for that. So when the previous Lambda terminates an EC2 instance used by ECS, a lifecycle hook is triggered. A lifecycle hook is something that you can configure in an auto-scaling group. And we've configured that lifecycle hook to emit a CloudWatch event, and then a CloudWatch rule puts a message in a queue when it sees that event, and then a Lambda is triggered based on messages in that queue. That Lambda calls the ECS APIs to begin draining, and then it raises an exception to put the message back on the queue. After the visibility timeout of the queue has passed, the Lambda is triggered again. It checks to see if the containers are still draining, and if so, it raises an exception and puts the message back on the queue. When it sees that containers have successfully drained, it calls the auto-scaling APIs to tell them that termination can proceed. There's a couple choices that I want to point out here. The first one is this CloudWatch rule. You can configure the auto-scaling group lifecycle hook to directly notify the queue. But using a CloudWatch rule allows us or you to subscribe multiple things to this event when it happens. So we could subscribe other queues to this event and take other actions. The second thing I want to point out is this queue Lambda pattern that we're seeing again. And Lee is actually one of the people that I talked to that was like, oh, I think I could have used a step function for this. The step function has a wait step that allows you to wait for a certain amount of time. And using a step function means that we don't have to set up a dead letter queue, and it fits the semantics of what we're doing here. We can say wait for a time frame and then check again. And we can add a condition step that says if we see that the containers have drained, we're done, otherwise check again. Reflecting on this work, what is the impact? What do we get from this? Lee saves time by not doing manual work, and Lee reduces error by not doing manual work. We can write tests around the code in the Lambda, and the third benefit is the increase in security. Patches are automatically rolled out in the background. So I hope this talk has given you another idea of how or when you could use Lambda, or a tip or a trick that you can use. But if not, I'll leave you with this. Are there places at work where you want to extend features? Are there services that you want to add functionality to? Like Lee, do you want to add a feature to ECS that AWS hasn't implemented yet? Or do you want to create CI/CD users when someone creates a new repository in GitHub? You can use Lambda for that. Is there work that you want to automate? Like Komal, do you want to automate a task that your internal users are doing? You can use Lambda for that. Is there code that you're running on your machine that would be more reusable or easier to build on if it were not on your machine? Like Kelly, do you have an analysis that you're running locally that you want to move off your machine? Or another example is a project Kamal's been working on to move a deploy script run in a local Docker container into a Lambda. Moving the code into a Lambda allows more engineers to deploy the service, since they only need the permission to invoke the Lambda instead of the permissions on the services that the Lambda is acting on. And I'll leave you with these 3 questions to think about as you think about where you might use Lambda. Does the work fit? Does the work that you want to do fit within the constraints of Lambda? When does the work need to happen? Is there a trigger that AWS provides, and they provide a lot of them, that matches when your code needs to be executed? And what do you want to spend your time building? Do you want to spend your time putting together a service, an ECS? What do you need to configure? What do you need to optimize for? Maybe a Lambda can get you to what you want faster. I'd like to thank all the engineers that took the time to share their expertise with me and talk to me about their experience of building with Lambda. So thank you, Kamal, Megan, Devon, Kelly, Ted, Lee, Andrew, Chris, Elia, Margie, Nathan, and Olivia. And thank you all for coming today. I'll be down here to answer any questions.